Alright, so what exactly is binary? What is the binary counting system? So to start talking about binary, I think, wow, this is really big. Let me make that a little bit smaller. Alright, so to talk about binary, I think it's important to start looking at the decimal system, or the number system that we're used to counting in. So this might seem a little bit simple or condescending almost, but stick with me for a moment. So if I write out the number 213, one way to think of this is it is actually can be broken down into 200 plus 10 plus 3, right? So this might seem obvious, and it sort of is, but it's important to think about why this works. So essentially what we're saying is that this is going to be 2 times 100 plus 1 times 10 plus 3 times 1. And this is more generally true for all numbers. So if I had the number 9876, so 9,876, this is actually broken down into 9 times 1,000 plus 8 times 100 plus 7 times 10 plus 6 times 1. So there's something that we can notice about these. They actually progressively add one more zero to the end. Another way to represent these place numbers is actually with powers of 10, right? So this is actually also equal to 9 times 10 to the third plus 8 times 10 squared plus 7 times 10 to the first. Anything to the first power is just itself. Plus 6 times, so to get 1, it's actually 10 to the 0. Anything to the 0th power is 1. Okay, so 9,876 can actually be represented as some digit times 10 to the third, digit times 10 to the second, so on and so forth. And this is more generally true for any number in the decimal counting system, the counting system we're used to. But it stands to reason that if we're going to be using powers of 10 to basically do counting, you could probably use powers of other numbers to do counting, and that's exactly what binary leverages. So in decimal, the digits that can go in these places range from 0 to 9. Because if you have 10, then you basically carry it over, right? And that's how we learn how to do long multiplication in elementary school. So in binary, actually, the digits actually range from 0 to 1. Or they're basically just 0 and 1. So binary numbers look something like this. And you've probably seen this in movies or TV shows or games or whatever. They just kind of look like this long sequence of zeros and ones. So with a binary string, so let's do something very simple like 1, 1. This is actually going to be your 2 to the 0th place, and this is going to be your 2 to the first place. So if you had a string like 0, 1, 0, it basically is actually broken down to 0 times 2 to the 0, 1 times 2 to the 1, and then 0 times 2 to the 0. And then you add all of these guys together and you just get 2. So this is 2. So let's try this for something a little bit longer and a little bit more complicated. So let's try 1, 0, 1, 1. So remember, this breaks down. You usually want to start from the rightmost just to keep it easy, or simple, I guess. So this is actually going to be 1 times 2 to the 0. And then the next one is going to be 1 times 2 to the 1. The next one is a 0, so it's going to be 0 times 2 to the 2, right? This is 0 times 2 to the 2, because we went 0, 1, 2. You just keep increasing the exponent. And so then over here you get 1 times 2 to the 3 we're at. Yeah, 0, 1, 2, 3. And so then this is equal to 2 to the 3 is 8. It doesn't matter what 2 to the 2 is because 0 is being multiplied by it, so we get 0. And then 1 times 2 to the 1 is just 2, and then 1 times 2 to the 0. Remember, anything to the 0th power is actually 1, so this is just 1. And so we get that 1011 in binary is actually equal to 11. Alright, so I hope that this video was educational, informative, and maybe slightly enjoyable to watch, and I hope you learned something from this. I thought the parachute problem was really cool. It was a very interesting, I guess, application or puzzle involving binary digits. And it's a good way to get people interested in sort of science in general because it is taking computing and computer science with astronomy and other disciplines of engineering like mechanical engineering and aerospace engineering. So I thought it was really cool. So this I'm basically considering as a bit of a bonus. So we discussed decimal base 10 counting, which is what we do on a normal basis, and then also we learned a little bit about binary. But as I alluded to before, there are all sorts of other bases. The common ones are obviously base 10 or decimal for humans. We have binary for computers, which is base 2. There's something called hexadecimal, which is often used to represent binary strings in more concise and human readable formats. And so this is base 16. And then there's something called base 64. It actually doesn't have another name as far as I'm aware, but it's just used as a way of encoding strings sometimes, especially over networks. So these are the common bases, and you can go and read about them, but I want to sort of discuss how to create an arbitrary base system. So you can use any number you want. Theoretically, you could have a base 1242 counting system. It would be extremely difficult to count in, and very few people would want to use it, but it's possible to create it. So I actually want to go ahead and create something that's a little bit easier to use and something that's not going to take us forever to create. So we're going to go ahead and create a ternary base, so base 3. So how do you go about doing this? So the first thing to remember is we need to create a set of digits that we can use. So in base 10, our set of digits were 0 to 9. In base 2, our set of digits were just 0 and 1. So you might see a pattern forming. Essentially, the digits that are allowable in any given base is basically 0 to n minus 1. So in the case of 10, we had 0 to 9, 10 minus 1. In the case of binary, we had 0 to 1 because 2 minus 1 is 1. So for base 3, the set of allowable digits would be 0 to 3 minus 1, which is 2. So we're only allowed to use 0, 1, and 2. And the reason for this, again, remember, it should be intuitive that if you allow n as a digit, it's the same thing as carrying it forward to the next position. So let's go ahead and think about this. So we have 0, 1, and 2. So what if you just create 1, 2, 0? So this is 120 in base 10. This cannot be created in binary because that 2 would not exist. So what is this in base 3? So we got to break this down, remember? So we get 0 times 3 to the 0. And remember, anything to the 0 is just 1. Then over here we get 2 times 3 to the 1. And then over here we get 1 times 3 to the 2. And so over here we would get 0, over here we would get 6, and over here we would get 9. And so this is 15. So this is equal to 15 in base 3. So let's go ahead and try creating one more base. Let's say we wanted a base 7, just for kicks. So remember, we need to come up with the set of allowable digits. So we can always start at 0, and then we go to 7 minus 6, this n minus 1. So that would be 6. Or, sorry, 7 minus 1, which is 6. So these are our allowable digits. I guess this should be a dash, not a comma. All right, so maybe we want a digit that looks like, trying to keep this simple so that it's not too hard to compute, 2, 3, 6. So this is 236 in decimal, but in base 6, this is actually going to look like, it's going to be, remember, start at the right-hand side usually just to keep your life a little bit easier so you can count up in the exponents rather than having to count down. So we have 6 times 7 to the 0, and then we have 3 times 7 to the 1, then we have 2 times 7 squared. So we add all these up, and we get, so 2 times 7 squared is 49 times 2, so that's 98 if I did that correctly. And then 3 times 7 is 21, and then 6 times 7 to the 0, remember anything to the 0 is 1, so we get 6. So now if we were to add these together, I guess we would get, well, I'm really bad at math. This would be 119 plus 6, so it's like 125, I guess. And so basically in base 7, the digits 2, 3, 6 is equivalent to 125 in base 10. So yeah, that's basically all I have for this video. If you found this mildly educational or mildly entertaining, please smash that like button and consider subscribing to the channel. Leave a comment down below so I know people are actually watching this. And yeah, I'll see you in the next one.